Now we will see the wind load Codal provisions. Now what we have to do is we have to calculate the design wind pressure, this PD. This is IS 875 part 3 and page number 9. This formula present on page number 9. PD is equals to, what is the formula? KD into KA into KC into PZ. KD into KA into KC into PZ. This is our formula. Now PD means design wind pressure. KD means, see here, KD means wind directionality factor. Wind directionality factor. This is KD. Okay, it's present in where it is present. KD wind directional factor is 7.2.1. How we have to consider these values 0.9 or 1? You can read, or I will explain in next session how to take and all these values. This is from which one it is? Clause 7.2.1. Clause 7.2.1. It's present in class 7.2.1. Page number 9. Okay. Now, what do you mean by KA? KA means area averaging factor. Area averaging factor. KA means it depends on tributary area. Now, what is tributary area? That we will see in next session. Where it is present KA? See here. This is the KA, and based on tributary area, we will take these values. If we have less than 10 meter square tributary area, then we have to take 1. If we have 25, then 0.9, and if we have less than 100, then it's 0.8. Sorry, this is not less than, equal to or 10. Equal to 10 or greater than 10. If we have, means we have to take this value. Okay. Now it is explained here, overall structure and individual elements and all. We will see in next session this. Now this is present on clause 7.2.2 table 4 we are using. Okay. Now KC means, see here, KC means combination factor, where we have to see the code is saying 7.3.3.13. Okay. So what do you mean by KC? Combination factor. Where we have to see 7.3.3.13. Okay. What it says, let's go and see. Yes, 7.3.3.13. Here it is. It's based on frames. See here, we have value KC 0.90 if we have these conditions means. Okay. I will explain you in next session for our building how to take this value. Okay. Now PZ means, see here, PZ means wind pressure at height Z. Wind pressure at height Z. It's in Newton per meter square. Okay. Now what is, how to find out the PZ value? Here it is. PZ formula is PZ is equals to 0.6 into VZ square. What is the formula? PZ is equals to 0.6 VZ square. Now what do you mean by this VZ? VZ is design wind speed at height Z. Design wind speed at height Z. Okay. Now what is the formula for this VZ? How to find out the VZ is? Let's go to, think it's in page number 5 or something. Yes, where it is, here it is. VZ means, this is the formula, VB into K1 K2 K3 K4. Okay. Now VZ equal to, I need some space, more space. So what I do, VZ equal to VB into K1 into K2 into K3 into K4. This is our formula. VZ means design wind speed at height Z. Okay. And VB means, let's see, VB here. Here it is VB. VB means basic wind speed, which is present in figure 1. Here it is figure 1. This is figure 1. We have to see here. If it's yellow color, then it's 39 wind speed, basic wind speed. Like this, we have differentiated. And also we have annex A based on major cities. We have that also. So it's maybe at last. It's present in annex A. See here, this is the annex A. As per our city, if you are present in Bengaluru, then 33 is our basic wind speed. If you are present in Pune, then 39. If you are present in Hyderabad, maybe Hyderabad is there or not. It's there, I think so. Yeah, here Hyderabad. If you are your building is in Hyderabad, then you have to take 44. Some are added in. Now we don't have in this code book. In amendments, some cities are added. We will see that one also. See here, Mumbai, it's there, Mumbai 44, Mysore 33. Like this, you have major cities. This is the wind speed at 10-meter height for some important cities. This is annex A. Okay. What we call it as basic wind speed. Basic wind speed. It's present in, we can see in figure 1 and also annex A. Right. Now what do we mean by K1? It's page number 5, I think so. See here, K1 means probability factor. K1 means probability factor, or we can say it risk coefficient. Risk coefficient. Okay. What code says? C 6.3.1. Here it is 6.3.1 risk coefficient, K1 factor. Figure 1 gives basic wind speeds. You can read this one. I will explain in next session how to take this for our building. Where we have to see this 6.3.1. What it tells? It tells about, go to table 1. Where it is table 1? Here it is table 1. Means for general structures, we are taking according to these wind speeds, we have to decide the value. If temporary sets are present, means we have to take these values. Okay, like this we use this table. Table 1. Okay, now K2 means terrain roughness and height factor. Terrain roughness and height factor. What code says? See this 6.3.2. 6.3.2 we have to see. Okay, let's go 6.3.2. See here, it is terrain height factor. it has category 1, category 2. Category 2 means 1.5 meter and 10 meter in between obstructions, means obstruction heights it's telling. And category 3 means this one. Okay, you have to read these, and according to these values, in what condition your building fits, you have to take that category. Okay, so this is 6.3.2, and another one is we have to use according to that category. Here it is the values in table 2. We have to take these values according to our building height, and according to terrain category we have to decide the values. Okay, what we use is table 6.3.2 and table 2 we are using to decide the terrain roughness and height factor. Now what do you mean by K3? K3 is topography factor. Topography factor K3 means C 6.3.3, code saying C 6.3.3. Okay, now what 6.3.3 says to us is here it is topography factor. Read this one. By using basic wind speed figure 1 takes into account general level sea above sea level. You have to read these and take the value. For more information, it's saying that use the annex C. Where it is annex C? It's present at the end. See here. This is the annex C. For more information, you can use this annex C also for K3. Means in K3 what we are doing? We are using 6.3.3, 6.3.3 and 6.3.3.1 and annex C for more information. Okay, this is our K3 value. Now what do you mean by K4? Importance factor for the cyclonic region. Importance factor for cyclonic region. What code saying is how to take this K4? C 6.3.4, C 6.3.4. Let's go to 6.3.4. Here it is, importance factor for cyclonic region 6.3.4 K4. You read this one and use these values for K4. Okay, I will explain you for our building how to take this importance factor for if our building is in cyclonic region. I will explain that in next session. Now our value comes VZ, and then we will put this VZ in here and then we will get the pz value, and pz we input here, and then what we get, our pd value, we will get the pd value. Now what we have to do is, we have to, if we have to calculate wind load on individual member, then what is our formula is, see here, wind load on individual members force, our formula is F equal to CPE minus CPE minus CPI into A into PD, right, into A into PD. What do you mean by CPE? CPE means external pressure coefficient. External pressure coefficient, CPE means. CPI means internal pressure coefficient. This is internal pressure coefficient. Okay. Now what do you mean by A? A means surface area of structural element. Surface area of structural element. A means, or cladding unit, structural element or cladding element. Okay. Now what do you mean by PD? PD means we already calculated design wind pressure. Design wind pressure, right, where we calculated, here it is, PD, design wind pressure, we calculated already. Now this surface area of structural element cladding unit is, it's calculated ETABS automatically, but still I will explain you in next session how to calculate this area. And what do you mean by CP? Where we get this CP is external pressure coefficient is, we will get this in, see here, this is our external table 5, we will get this external pressure coefficient. According to this building height ratio and building plan ratio, our wind theta equal to 0 degree and 90 degree, our CP pressure is, we have to take according to this. Okay, I will explain this how to take and all, don't worry, in next session I will explain clearly. Okay.